Good afternoon, my name is Javier Rodriguez, and today we'll be working on chemistry. Here's the name of our chem class. So today, for chemistry, we'll be doing two practice exercises. The first one involves balancing equations, which is basically taking an equation and making sure that all the elements and compounds in that are reacting and in that equation are balanced and are equal amounts. So this is the equation that we are giving originally. We have Fe2 plus, which stands for iron 2 plus. This over here is a charge. Keep that in mind for later. Let me make it another color so that you can distinguish it. Alright. So that's our charge. Now you have to sum that plus H plus, which over here we have another charge, which you really should keep in mind for later. And then you add that plus NO3, which is nitrate. Those are the reactants in our reaction. Now over here, after this, or you can go downstairs since we don't have a lot of space here, we have Fe plus 3, which as you notice is iron as well, but has a different charge, which means it's different, and that's very important for later on. Plus NO, not NO3, just NO, plus H2O, which is water. Right. So we want to try and have everything in the same amounts. While there's many ways to solve this, I think the best way to start to solve this is that we make sure that we make sure to take some time to watch everything. Make sure you see the amount of NC. You see we have two things that are similar, but they don't have the same charge. We also have H, but this one has a charge, while H2O doesn't have a charge because it isn't a compound. And these are things that we have to keep in mind when we're balancing the equation. Now, if we go to a new page here, we can break this exercise into different pieces. Alright, so the first part I think we should work on is simply balancing the ones that don't have charges. As you notice, some elements like iron, Fe plus 2 and Fe plus 3 have charges. So we should just work on the first ones that don't have charges. On the reactant side, we had NO3. And on the other side, we simply had NO plus H2. Now, if you notice, immediately here we have NO3. So we have 3 oxygen equals 3. Here oxygen equals 1 and oxygen equals 1. When we do add these, it still won't be 3. So what way do we find so that we make O equal 3 in the product side? Now, in order to do this, what we can do is we can go either change NO3 or change H2O, which is water. However, if we did change NO3, we're going to have problems because N over here is 1, so it's already balanced. There's no need to change that. But over here, we notice that H2O, keep in mind, we only have 1 mole of H plus here, which we can change because it is by itself. So what we can do is that we just simply put a 2 here, making this O2. And now O1 plus O2 is going to equal 3. So there we have our first balancing. Now, once we have that, that means we're going to have to change the amount of hydrogen that we have on the other side. Since we only had 1 of hydrogen, and here we have 4 of hydrogen, it's simply multiplying it by 4. So we're going to have 4. Now, almost everything is balanced except our iron. It's very important that our iron is balanced, but this will be a bit trickier because it has its own charge. So we have Fe plus 2 plus H plus, because H plus also has a charge. You have to put all the things that have a charge in the same equation. So this and all leads up to Fe 3 plus. Oh, my bad. Fe 3 plus. So now remember, we did change this by 4. So basically over here our plus is going to equal 2 plus 4, which is 6. Now that is simply incorrect, because here we're going to have a charge of 6 in total. Here we just have 3. We could just put 2, but this will end up being incorrect because it won't be in the same, because we won't have the same ratio. So what we do is we put a 4 here. So now 4 times 3 equals 12, and we put another 4 here because we want FE to be in the same amount. So had we put 2 here and 2 here, we would have had different amounts, because here we would have had 6, here we would have had 2 times 2, which is 4, plus 4, which is 8. So we will not have the same amounts. We keep doing this until we notice that we need 4 times 2, which is 8, plus 4 times 1, which is 4, is all equals 4 times 3. And then we have 12 over here, and this is 12 as well, so we have 12 times 12. All this amounts to our balance equation being this: FE plus 2, oops, sorry about that, FE plus 2 with a 4 times 4 H plus NO3. And this won't have anything here. And now over in the other side, we'll just have 4 Fe plus 3 plus NO plus 2H2O. And that will be our balance equation. So there, I hope you learned a little bit about balancing equations. Now, for our next exercise, we're going to have a dilution exercise. The exercise states if 25 milliliters of 0.5 molarity NOH neutralizes 25 milliliters of monopratic acid, what is the molarity of the acid? Well, you might think that monopratic acid is a very big word and you need to know what it means. You don't need to know what it means for this reaction. For this reaction, you simply need to know what simply need to know the formula Me1B1 equals Me2B2. This means that our initial molarity times our initial volume equals our final molarity times our final volume. Now, if we reread the exercise, we find out that our initial molarity is going to equal 0.5 m NOH. We have to multiply this by our initial volume, which is 25 milliliters. But since molarity is always in liters and we want to cancel here, we're going to have to convert those milliliters into liters. So 25 milliliters, go over here, times 1,000, so we can cancel our milliliters, and then over 1 liter, because 1,000 milliliters equals 1 liter. Now we cancel our milliliters, we'll be left with 0.25 liters. 0.025 liters. So we have that amount. Now, since we're changing volumes, we should also change our final volume, which is going to be 35 milliliters. We should also change that so that we don't have any further problems with our equation. So now we have 35 milliliters, and to convert it to liters, we have 1,000 once again. Excuse that, there's not a lot of space here. Which is going to equal 0.035 liters. So now that we have everything in liters, we can go and write our full equation. Excuse that. Now, as if you recall, our initial molarity, or M1, is going to equal 0.5 m NOH times our initial volume, which is 25 milliliters, equals M2, which is what we're trying to find, which is the final molarity of the acid, times the final volume, which is 0.0. Oh wait, excuse this over here. Keep in mind, I forgot to change. Remember, we have to change this to liters. That's very important. So that's 0.025 liters equals M2 times B2, which is 0.035 liters. Now we have that, we simply divide this side by 0.035, so we can cancel this and leave the N2 by itself, and divide this by 0.035 liters. That dot there. Now remember, since molarity is moles over liter of solution, this liters will be cancelled by this one, and we'll simply be left with moles over liters, which is the same as moles over liters, which is basically molarity, which is what we have here. So we needed to do that. We need to see if we didn't change this to liters, we will not be able to do that conversion. So upon doing this, we take our calculators and we do this part right here, and we get the result. M2 equals 0.357 molarity. Or if, since we're using sig figs, we have to use the amount with the least sig figs, which in this case has only one sig fig, so it should equal 0.4 molarity. So that will be the final concentration of our acid, or the final molarity of our acid, which is what we were trying to find. Now I hope you have enjoyed this interactive lessons, and I hope that you learned a little bit about chemistry today. Thank you for your time and have a good day.